is vector addition warm-up, and this is built around projectiles. And so we're going to talk about a football, which is a projectile. It's in free fall, and it travels in two directions, right? It travels in the Y direction, up, and it travels in the X direction, forward, okay? And I'm just going to draw a picture of what that looks like. So I've got this ball, and this guy kicks the ball. It goes up like this, and then it comes back down, and it's going to hit the ground, okay? Here's how it's traveling. So there's a ball here, right? And it's moving along, okay? And you can see the path of the ball takes to come to the ground, okay? Right before it hits the ground, it has a vertical velocity of 4 meters per second downward, okay? So that would be this vertical velocity right here, and that'd be 4 meters per second downward. It has a horizontal velocity here of 8 meters per second, okay? Now the resultant velocity of this ball is basically along the arc of its travel, okay? So this is the arc. So the resultant velocity when it hits the ground actually looks like this, okay? This would be the resultant velocity VR. I just call that VR, okay? This would be the vertical velocity. I would just call this like Vy, and I would call this like Vx, okay? Okay, so let's talk about it. So I'm going to blow this up a little bit so you can see it. So we've got a vertical component of the velocity, which is 4 meters per second. You've got a horizontal component of the velocity, which is 8 meters per second. Notice these are broken into two parts, and they're 90 degrees from one another. So this is a right angle, okay? And I want the resultant velocity, which is basically the sum. And when asked for the final resultant velocity, it wants the sum of these vectors, the sum of the vectors. So to add the vectors up, I put the vectors head to tail, head to tail. So this is the tail, head, head. And then I go from the first tail to the last head, okay? So the resultant velocity is going to be down and to the right, okay? So for this case, the ball is going down, you know, it's coming back to the ground, right? And it's also going to the right, okay? Now I want a magnitude here, so I'm not going to worry about the sign. These are both going to be positive, okay? So I want to find this resultant vector right here, VR. Well, this is sort of like Pythagorean theorem. So I can say, oh, okay, it's a right triangle, a squared plus b squared equals c squared. Well, I know a and b, okay? So a is 4 squared plus 8 squared, and this equals c squared. So if I go through and do this math, what I'm going to get here is 80 equals c squared. And if I take the square root of 80 to get c, remember the answer to this is not 80, it's c, it's not c squared, it's c. If I take the square root, the magnitude of the resultant velocity is 8.9 meters per second. That's the magnitude, okay? Okay, the direction would be down and to the right. Okay, now you notice something about this, that this is a check on your answer. Since this is the hypotenuse of this triangle, so sum of the vectors, it's longer than either of the two sides. So the two sides are 4 and 8. Well, this is 8.9, and that's the way it should be. So if you get a VR that's less than 8, you know you have a problem, okay? So it has to be bigger than these two sides since it's a hypotenuse. So that's how you find the final resultant velocity of a football that's being kicked and coming down to the ground, forward or to the right and down. And basically you add the vertical component and the horizontal component together using the Pythagorean theorem to get VR, okay?